you go for carbon, if you go for diamond, carbon diamond continuation, that is, it has tetrahedral units. Tetrahedral units. These tetrahedral units can be shown in the form of a cubic cell like this. That is, you can just take, this is the cubic cell. This is the cubic cell. You just mark one tetrahedral link like this. Here I can take here this is one tetrahedral link, and then here also you can take one more tetrahedral link. Here also you can take one tetrahedral link. So this is giant three-dimensional structure of diamond, and each dot represents a carbon here. Each dot represents a carbon. If you go for graphite, it has hexagonal units with layered structure. Suppose if I take, these are the hexagonal units. These are the hexagonal units. These are the hexagonal units of the graphite. So here you can take one more hexagonal unit like this. Hexagonal unit, and you can see that this is so these are the layers. The distance between the two layers is given by 3.35 angstroms, and these layers are separated by weak van der Waals forces, and that's the reason this is giant two-dimensional structure of graphite. Each carbon, each dot in the hexagonal unit represents a carbon unit, and this is the individual hexagonal unit. It is the individual hexagonal unit, and the distance between the two carbons is around 1.42 angstroms. So when this graphite, from this we can understand that this graphite, when graphite comes in contact with graphite layer, when comes in contact with water, the layers in graphite slide against each other. Because of this layer slide, the graphite becomes soft, and it is used as a lubricant. That's why graphite is used as a lubricant in industries in order to prevent wear and tear in machines. The graphite powder is used as a lubricant, and it is because of the Same reason it is also used, graphite is used in the pencils. In pencils, we call the pencils as graphite pencils. Graphite pencils. And this graphite powder, because of its soft nature, it can be easily erased with the eraser, because the forces in the graphite powder, the hexagonal rings which are present in the graphite powder, that doesn't have strong forces on the surface of paper. So you take an eraser and you rub it, you can see that the graphite layer can be easily removed with the eraser. That's the reason we always say that graphite is always soft, and it is also a good conductor of electricity. And graphite is a good conductor of electricity because it contains a free electron, because each carbon in the graphite is undergoing sp2 hybridization. When it is undergoing sp2 hybridization, it contains one free electron. It also contains one free electron. And if you go for diamond, many other properties can be attributed for diamond. Because of its glittering nature, it glitters, and it shows total internal reflection. Total internal reflection. It has high refractive index. Which is equal to 2.45. It has high refractive index which is equal to 2.45, and density also is very high. And here the distance between the two carbons is around 1.54 angstroms, and the bond length between the two carbons, this bond length is 1.54 angstroms, and each carbon in diamond undergoes sp3 hybridization. Here also, if you take the bond angle in diamond between adjacent carbons, diamond bond angle is 109 degrees 28 minutes. Here the bond angle is between any two carbons